Hi, welcome to another 4AC video. This time we want to look at quiz 6 that we have just completed, and I hope I video this solution so that you can do your revision in case you've forgotten what we have discussed. Now the quiz comprises of two questions, question 1 and 2. In this video we look at question 1. Now question 1 refers to the figure 6.1. And it wants us to calculate the time constant of the circuit when the switch is closed and the steady state value of IL and VL, VT or VL, right? And subsequently the switch was open, and then we want to determine the new time constant and to calculate the values of the current IL and the voltage VT initially. Initially means immediately after the switch was open. Okay, let's see how we can handle this type of questions. All right. So this question has two parts, part A and part B. Part A is when the switch is closed and after a long time. Now, after a long time means that, by definition, when the time is greater than 5 tau. Now, first is to recognize what kind of circuit is this. Now, you can see that there is a resistance, the two resistors and two inductors. So basically, this is a RL circuit. And because there is a 20-volt DC supply there, we can conclude that this is a inductor storage stage. Storage stage means that when the switch is closed, the current flowing through the inductor has a characteristic such as this. It means initially the current was 0, and then it slowly comes up until it reaches a maximum value I. Reaches a maximum value I, maybe I call it IM. Alright, and at the same time, the voltage across the inductor started with the maximum and then slowly taper off until it reaches 0, where the initial voltage Vmax is the voltage of the battery. So we have VL. Now, so at steady state, the steady state means that after the time greater than 5 time constant, what is required is what's the value. Now, the first part of the question wants us to calculate the time constant. Now, if you look at this circuit, the circuit can be reduced from this circuit can be reduced to a Thevenin equivalent circuit of such things. Okay, so I have one resistor here and one resistor here and one inductor. So my equivalent resistance T is two resistors in parallel, so I can calculate as R1, R2 divided by R1 plus R2, which gives me 100 times 50 divided by 100 plus 50. That gives me 100 over 3 ohms. Whereas the total inductance T is just 80 plus 120, so it's 80 plus 120, that's 200 millihenry. Right, therefore, the time constant for this circuit is L over R. It's equals to 200 millihenry over 100 divided by 3 ohms. That gives me 6 milliseconds. Next, I want to know what is the ILT after steady state. That means after 5 tau. Now, after steady state, the inductor appears as a short circuit. So the final current is V over R1, which is 20 divided by 100, which is 0.2 amps. And IRVL after a long time steady state will be just 0, right? That means at this point and at this point. Okay, and part B is when the switch was open. Now, when the switch was open, or it's open, at time t equals to 0, when switch was open at time t equals to 0. That means we say the initial values of I, L, and VL. Now what happens is, in the storage phase, after a long time, this current is 0.2 ampere. So when the switch was open, at that moment in time, the current remains the same. That means the current remains at 0.2 ampere. Okay, this means the voltage at time 0 is equals to the maximum I value, which was this one, multiplied by the effective resistance. Now this time the effective resistance is R2, because this is the circuit, so the new circuit will be just like that, right, where the IL is flowing this way, and the voltage now effectively is the reverse. Okay, so V is just the opposite direction. That's why I put a minus sign in front there. 0.2 times the resistance was 50 ohms. So that gives me minus 10 volts. So please take note that an inductor has this very unique characteristic, that when this switch was open, the inductor's first reaction is to keep this current going, right? So whatever was the maximum current then was carried through to here. But now this current is flowing through an effective loop this way now. Now if you go on this way, the voltage generated across this resistor, or in other words, the voltage across this inductor, is now opposite direction, minus 10 volt, right? And it's calculated by the maximum current and the resistance. So that's a very unique feature of an inductor. So please take note of that. Right, and the new time constant of the new circuit now, which is just comprises of the inductor and the resistor, will be just tau 2 is L upon R2, which is 200 millihenry divided by 50 ohms. So that gives me 4 milliseconds. So please take note that the time constant when the circuit was closed and the time constant when the circuit was open are slightly different. Alright, that's all for this video. We shall continue with another video for question 2.